We're going to talk about section 5.1 and 5.2 today. Focus is going to be on some of the interior and exterior angles of polygons. First thing we've got going is this sheet that you should have filled out yesterday. And if not, follow along with me and we'll go from there. Find the sum of the angles of the quadrilateral. If you're going to go through and add up all of these angles, you are going to get 360 degrees. Next thing, find the sum of all the angles of two triangles. Well, if we have two triangles formed by the one diagonal, we have 2 times 180, and we have 360 degrees. Moving over to the pentagon, find the sum of the angles of the pentagon given here. Going through and adding those up, we will get 540 degrees. As we do the sum of the three triangles formed by the two diagonals coming out of one vertex, we know that three triangles, each measuring 180 degrees, needs to be 540 degrees. At this point, we should recognize a pattern. As we move on to the hexagon, six-sided figure, add up our angles given, and we get 720 degrees. And the sum of all angles of the four triangles, 4 times 180, gives us 720. And finally, the heptagon, the shape that we probably know the least about, seven-sided figure, go through, add up the angles, we get 900 degrees. Not surprisingly, we take our 5 triangles and multiply times 180, and we get 900 degrees. Now that we have our beginnings of our worksheet filled out, we're going to use these values. You're going to refer back to them. I'm going to move on to the next one. It says number of sides of the polygon. I've got my 3, 4, 5, all the way up to 9, and then we'll make some conjectures about n-sided polygons. The number of diagonals that can be drawn from one vertex. As we saw in chapter 2, I believe, we know that there are no diagonals drawn from one vertex of a triangle. Quadrilateral, we just worked with that example that has one diagonal from each vertex. Again, important to note that we're talking about diagonals from one vertex as opposed to diagonals from all the vertices, or all the diagonals that can be drawn, excuse me. 2 diagonals for a 5-sided figure. Hexagon has 3 sides, and we should see our pattern, fill it out, 4, 5, 6. Taking a look, if we remember correctly, we can't draw a diagonal to a vertice, its own vertice, and to the two next to it, and that's where we got our n-3 formula. So we head over here, n-3. Whoa, n-3. Let's try that again. For our number of diagonals that can be drawn from one vertex. The number of triangles that can be formed. When we look at a triangle, even though there's no diagonal, there's still one triangle there. We look up above at the problems that we just did, and we know that there are 2 triangles when we draw in a quadrilateral. 3 triangles for a pentagon. Hexagon has 4. Heptagon has 5, and we can see that a octagon has 6 and a nonagon will have 7. Hopefully we understand that the number of triangles drawn number of triangles formed when we have a diagonal drawn from one vertex is n-2. Sum of the interior angles of each polygon. We did the 3-sided figure, and we've done that in some previous chapters. From up above, we have a quadrilateral, 360 degrees. Of course, these are all degrees. And then we have 540 and 720 and 900 and 1080 for an octagon, and little known fact that a nonagon has 1260. Now, we're going to base this on n being the number of sides. If the number of sides is 3, we kind of look at this as we have one triangle in there from up above, one triangle. Each triangle is 180. Here we have two triangles. 2 times 180 is 360. Three triangles. 3 times 180 is 540, and so on and so forth. So I'm going to move this down here because I write too large. But we're going to say that our sum of the interior angles for each convex polygon will be n minus 2 times 180 degrees. Next thing we're going to do is continue on with our worksheet, and it brings us to talking about exterior angles. The sum of the exterior angles, one drawn at each vertex. The first thing we need to do is figure out what is an exterior angle. We talked about that in chapter 4, but let's take a look at an example that we have here. This was done in Sketchpad, obviously. Now remember, exterior angles, this is kind of hard to read, but they've been added up here. Each of these interior angles, or excuse me, each of the interior angles of this regular pentagon is 180. So if we took a look, not 180, 108, excuse me, 108, 108, 108, and so on and so forth. If all of these are 108, each of the individual exterior angles, remember an exterior angle will form a linear pair with its adjacent interior. So 108, and that makes this 72. Go look up here. Each of these angles is 72. Shouldn't be surprising because they're a linear pair with those interior angles. So if those are all 72, we have 1, 2, 3, 4, 5 of them that measure 72 degrees, which tells us that the sum of the exterior angles of a regular pentagon is 360 degrees. Well, that was for a pentagon, 360 degrees. Let's take a look at what it might look like with a regular triangle. We take a look at a triangle, and let's call those all 60-degree angles. And then when we, 60-degree angles. And each of the exterior angles, do you agree that my exterior would be 120 and 120 and 120? And if I have three angles, each measuring 120, 120 times 3 will give me 360 degrees. Now, if we take a look at a square, which is a quadrilateral, I've got four 90-degree angles. The exterior angle of a 90-degree angle will be 90 degrees. And if I have four of them, I have four of them at 90 degrees. So 90 times 4, not surprisingly, 360 degrees. We should be able to make a conjecture that the sum of all the exterior angles, one drawn at each vertex, will always be 360 degrees. And if you think about a circle, going around a circle, it's 360. So all the way around, all of the exterior angles will always be 360 degrees, even if we're talking about n being the total. So we've got our charts filled out on our worksheet, and now we're going to take a look at some, we'll use some of our information just to get it all in one concise spot. The sum of the measures of the four angles of a quadrilateral. Okay, that's probably one that we've known our entire life. Sum of the measures of the four angles of a quadrilateral, 360 degrees. The sum of the measures of the interior angles of a convex polygon. We just looked at that one not too long ago. The sum of the measures of the interior angles. It's always going to be n minus 2 times 180. Next one, the sum of the measures of one set of exterior angles of a convex polygon. That comes directly from this chart up here. Always going to be 360 degrees. Probably the easiest question you'll be asked all year. What's the sum of the measures of the exterior angle of a 22-gon? 360 degrees. No matter how many sides you have, it's always going to be 360. Please make note that these ones say sum, sum, sum. When we get down here, we are talking about one exterior angle, one exterior angle. Now we're also talking about a regular polygon. Regular polygon is a polygon that has all of its measures going to be equal. So we're talking an equilateral triangle, a square, they just showed you that regular pentagon that had all 108 degree angles. So when we're talking about one exterior angle, if all of them is 360 degrees, how are we going to figure that out? We're going to take 360 divided by our number of sides. So when they ask about one exterior angle, you're talking about 360 divided by n. Then, if we're talking about one interior angle, well, we just said the sum of the interior angles is n minus 2 times 180. So if I want to break that up into, how do I figure out what each individual ones is, since they're all the same? I'm going to drop her down here. It's going to be n minus 2 times 180. N minus 2 times 180 divided by n. We're going to divide by the number of sides, which is the number of angles as well. That's going to get that done for us. There's two blanks here because we also could use, our little algebra. This would also be equal to, if I did 180 times n minus 360, all divided by n. And now if I split this up and put 180 over n, I get 180 minus, and I get 360 over n. Now, so n minus 2 times 180 divided by 1 is one way to do it. Second way to do it is 180 minus 360 over n. Hey, where did we see 360 over n? It was the measure of one exterior angle of a regular polygon. Well, doesn't it make sense then that one exterior angle of a regular polygon and one interior angle of a regular polygon are a linear pair, and together a linear pair totals 180. So if we've got 180 minus 360 over n, we know that we have a linear pair. Coincidence? I think not. Next step after we completed that chart is to take a look at a couple of examples. You don't have these examples in front of you, but there will be some of these that will come up in your homework. So now would be a good time to pay attention. It says here, one exterior angle of a regular polygon measures 10 degrees. A couple of important pieces of information right there. Going to start with the fact that they said one exterior angle measures 10 degrees. It's also a regular polygon, 10 degrees. What is the measure of each interior angle and how many sides does it have? There's more than one way to do this problem, but I would, if it's talking about one exterior angle, you're talking about 360 over n. That was the formula we just created for one exterior angle. And if that's equal to 10 degrees, there's a few different ways we can do this problem. We can take and multiply both sides by n, and then we have 360 equals 10n, and n equals 36. That's one way that we can figure out the number of sides for this angle. Now, it said one exterior angle is 10 degrees. We could go plug our n equals 36 into the formula for n minus 2 times 180, but doesn't each exterior angle and interior angle have to form a linear pair? Which means if it's 10 degrees for an exterior angle, its interior angle must be 170 degrees. That's not a very good looking 7 I got there. Let me try that again. 170 degrees is a little bit big as well. Okay, so we've got a 36 gon that has each exterior angle measuring 10 degrees, each interior angle measuring 170 degrees. Next problem. The sum of the measures of the interior angles of a regular polygon is 2,340 degrees. Again, what's the important information that they gave me? We're talking about a sum, which means we're talking about all of them. We're talking about the interior angles, which means we are probably talking about n minus 2 times 180. That's the entire sum of them, and they measure 2,340 degrees. How many sides does it have? We're going to be searching for n. How do we solve a problem like this? Two different ways. We could distribute the 180 if we so chose, or we can go ahead, I prefer to divide by 180 right out of the chute. Divide by 180, divide by 180. I get n minus 2 equals 13. Now, does that mean this is a 13-sided figure? Oh, hold the phone. We got to add 2 to both sides, and we get n equals 15. So they asked us, how many sides does a polygon have if it measures 2,340 degrees for all of its interior angles? This is going to be a 15-gon. N is equal to 15. We're going to skip ahead here and do a couple more word problems, so bear with me. Here we go. Okay, last couple working with our equations. Excuse me, formulas. How many sides does a regular polygon have if each exterior angle measures 30 degrees? Very similar to the problem that we just did. Again, we're talking about each exterior angle, and we're talking regular polygons again. So each individual exterior angle is 360 over n equals 30. We can go ahead and multiply by n and then divide by 30, or we could understand a little algebra. We could set up a proportion if we want. Either way, we're going to end up doing 360 divided by n. We could cross multiply, or you can understand that those are going to end up 360 times 1 divided by 30. So 360 over 30 is 12. This has 12 sides. How many sides does a polygon have if the sum of the measures of the interior angles is 3,960? We did one just like that a second ago. Let's try n minus 2 times 180 equals 3,960. First thing we need to do is divide both sides by 180, which gives me n minus 2 equals 22. Please be careful. It's not a 22-gon. As you may know, we have to add 2 to both sides, plus 2 and plus 2. I get n equals 24. 24-gon has the sum of the interior angles as 3,960. Last two, a little bit different. If the sum of the measures of the interior angles of a polygon equals the sum of the measures of its exterior angles, how many sides does it have? Now, some of you probably already figured this one out before we're even done talking about it. There's a few different ways you can do it, but when is an interior angle equal to its exterior angles? Probably, since they're a linear pair, that's going to be when they're 90 degrees. What kind of a figure has 90-degree angles? Well, it's probably going to be a four-sided figure or a quadrilateral. What if you didn't know how to do that? Well, you could say 360 over n equals n minus 2 times 180. Could you solve this for n? Absolutely. It's a little bit easier to kind of figure out what we're talking about there, but that is definitely solvable. Moving on to number 7. If the sum of the measures of the interior angles of a polygon is twice the sum of its exterior angles. Oh, I think I read the last one wrong. Let's take a quick look at this again here. I think we were talking about the sum, and I did it as 1, which incidentally we should end up with the same answer. The sum of the measures of the interior angles equals the sum of the measures. So if we were talking about, it's going to be four-sided, but let's talk about, it should be what? 360, that's the exterior angles, equals n minus 2 times 180. Okay, divide both sides by 180, and I get 2 equals n minus 2. 2 equals n minus 2. Add 2 to both sides, n equals 4. So it worked out either way. When is it going to be 360 for the interior and 360 for the exterior? So there is my example of reading carefully sum. Because as we look at the bottom one, if the sum of the measures of the interior angles is twice the sum of the measures of the exterior angles. So if I know the interior angles are n minus 2 times 180, and I know the exterior angles are 360, but it says that it's going to be the interior ones are 2 times the exterior ones. Now we can solve this problem. Again, I would divide both sides by 180, and we're going to have n minus 2 equals, this is going to cancel to 2 over 1, 4. Add 2 to both sides, n equals 6. So this last one would be a 6-sided figure. So I didn't read carefully on number 6, but we got the job done, didn't we? I think that concludes what we're going to kind of go through on here. If you need to review this, this will be posted on your Schoology account, so you can review it at your own time. And now you should be able to definitely be working diligently on your Chapter 5, Day 1 homework.